watching this video from justtutors.com. In this video, we are going to learn about factor theorem. But before moving to our today's topic, we'll try a warm-up question. Here's a question for you. To try this warm-up question, you can pause the video. So as you can see that in question number 1, there are some more parts that need to answer according to the polynomial given px to us. So first of all, we need to find out the coefficient of x raised to the power 4. So we look at the term which is x raised to the power 4, then we look at the coefficient of it, which is minus 26. So the answer is minus 26. The next is we need to find out the degree of the polynomial px. So the degree of this polynomial 15x squared minus 26x raised to the power 4 plus 57x cubed minus 96. So as we can see that the highest power is x raised to the power 4. So the degree of the polynomial px is 4. Now the next is we need to find out the constant term out of the polynomial. So the constant term, as you can see, that is minus 96 without any variable. The next is number of terms. Now we need to count the number of terms in the given polynomial. So that would be 1, 2, 3 and 4. So the answer is 4. Now we move ahead to our topic, which is about factor theorem. And factor theorem says that if px is a polynomial of degree n greater than or equal to 1 and a is any real number such that pa equals 0, then x minus a is a factor of px. So there is a polynomial px which is a dividend. So as we all know that dividend equals divisor times quotient plus remainder. So as we all know that dividend is px, divisor is x minus a. Let quotient be qx and remainder be rx. Then if we put x as a, because a is any real number, then we get pa equals 0 times qa plus rx, or we can say ra, which implies that pa equals to ra. So as we all know by remainder theorem, px can be written as x minus a times qx plus pa, because pa is a constant. So remainder is a constant here. Why? Because the degree of the remainder should be less than 1. So the less than 1, that means the degree of the remainder is 0. So degree of the remainder is 0. This means that remainder is a quotient. So by remainder theorem, we can say that px equals x minus a qx plus pa. So in place of rx, we can put ra, and in place of ra, we can put pa. Now as it is given that pa equals 0, so this means px equals x minus a times qx. So this implies that x minus a is a factor of px. Now we move ahead and we're going to prove the converse of the theorem. So now we'll take that x minus a is a factor of px. So then if px is divided by x minus a, the remainder must be 0, because x minus a is a factor of px. For example, 3 is a factor of 15. So if 3 is a factor of 15, so that means if we divide 15 by 3, so it's 5 here, 15 here, and the remainder is 0. Similarly, if x minus a is a factor of px, the remainder must be 0. But by the remainder theorem, px when divided by x minus a gives the remainder equal to pa. So as we have already learned that the remainder theorem says that if px is divided by x minus a, this will gives us a remainder as pa. But by these two statements, we can say that pa equals 0, because x minus a is a factor of px. Now we move ahead and we're going to try a question on factor theorem. So the question says that gy is a polynomial and we need to show that y plus 4 is a factor of gy. So to check that y plus 4 is a factor of gy, we need to check that the remainder should be 0. So that means y plus 4 equals 0. This will give y as minus 4. Now we substitute the value of y as minus 4 in the given polynomial gy. If this is equals to 0, we can say that y plus 4 is a factor of gy. So now we put y as minus 4 in this polynomial and we get g at minus 4 equals 0. So since the remainder is 0, so we can say that y plus 4 is a factor of gy. So in this way we can use the factor theorem to check whether the given divisor is a factor of the polynomial or not. Now we move ahead to our practice questions. Here are some practice questions for you. To try these practice questions, you can pause the video. Now here comes the answer of these questions. You can match the answer, and I must say that you should pat your back as you're working really good in understanding the factor theorem. Thank you for watching the video. For more, please visit justtutors.com.